Howdy folks! A rock buddy of mine had a specimen that he wanted me to try to identify. It was probably about yay big, kind of a little bit on the thin side, maybe about a half an inch thick. And I said, well, break off a little piece and I'll dissolve it in acid and try to find out what it is. So I don't have the rock with me. I let him do the dirty work so I didn't ruin it. But he did give me a little piece, so I brought it home. And the actual rock or mineral, like I said, kind of had a good heft to it. It felt pretty heavy for its size. It was kind of a tarnished color. And actually had some spots that were kind of iridescent. So it was kind of grayish, silvery, and even had some kind of bronze sort of tinges to it. I did take some pictures. The first picture is kind of the surface of the rock, and the second picture is the edge where he broke a little bit off. And where he broke it off, you can see it's definitely really silver on the inside. So I'll post those right now so you can have a look. He was thinking it was either Chalcopyrite, Pyrite, or Galena, and I thought those were good guesses and easy enough to test for. So I figured it would be pretty easy to differentiate between the Pyrite, Chalcopyrite, and Galena. They're all sulfide, so I could just test for sulfide and just confirm that it's one of those. And the only difference between those three is the Pyrite is an iron sulfide. The Chalcopyrite is an iron copper sulfide, so that has copper in it. And the Galena is a lead sulfide. So I think instead of doing a full-blown analysis, pulling out my trusty book, Orsino Smith, Identification and Qualitative Chemical Analysis of Minerals. I don't know if that comes out on the camera. But he does have a table here for a series of 3 drop tests. Basically, you use a little spot plate and you put a little drop of your testing, the solution that you want to test, which is actually the mineral that you've dissolved and gotten into solution somehow. And there's 3 tests. One is using, you put a drop of ammonium carbonate with one. The other one you add an ammonia sulfide solution. And the last one you add a potassium iodide solution. And I'm going to try to take a photo of this chart here of those 3 items and the different metals associated. And the different metals will have different reactions. For instance, the let's say the copper, for the first ammonium carbonate, it should turn green to blue if there's copper there. With the ammonium sulfide, it should turn black. And then the last one should be white, changing to pink, green, or yellowish, reddish yellow. So if that happens, it's copper. Iron, the ammonium carbonate will be brown. The ammonium sulfide drop will turn black, and nothing will happen with the potassium iodide. Now the lead looks like it has the biggest biggest indication. The first one with ammonium carbonate, it should turn white. The second ammonium sulfide should turn black, and the last one, the potassium iodide, should turn bright yellow, which is kind of the confirmation test for lead. So anyways, that should really tell us what we need to know. So that should be pretty painless. Here's a photo of that table for your reference. The first thing that I've done is I've ground up the sample and I stuck it under a stereo microscope. I just wanted to get a quick look at it. And there seems to be a fair number of fractures that are at a right angle. And that would be indicative of a cubic or isometric crystal system. And that would include galena and pyrite, but not the chalcopyrite, which I believe is tetragonal. I'm going to try to get a picture or two and get those posted here so you can see, or if you can see, it's not really, overwhelming, but there does seem to be a number of fractures that are at that 90-degree angle, so that might be a clue. The next thing we need to do is dissolve the material in acid. Galena is soluble in hydrochloric, but I don't think pyrite or chalcopyrite is, but they should all be soluble in nitric acid. Definitely continues to give off gas upon heating in the acid. I did throw some lead acetate paper at the mouth of the test tube with the gas coming out. It did turn dark, so that's indicative of a sulfide, which would be the case if it's either pyrite, chalcopyrite, or galena. But I just wanted to check. The metallic color of the mineral is also very indicative that it's a sulfide. We're going to take what we dissolved in acid, take a few drops, and do a series of spot tests. I have 3 compartments on this microscope slide. I'm going to put 2 drops in each compartment. And then, to the first one we'll add ammonium carbonate solution in it. And we're going to get some fizzing because of the acid that we dissolved it in. Yep. And I don't know if you can see that, but it's kind of a whitish, it's a bit more of a beige, but definitely a precipitate. Now we're going to add a drop of ammonium sulfide to the middle one. Wow. Definitely black. And the last one is potassium iodide. Wow. So the potassium iodide, or the last test, is kind of a standard confirmation test. The other 2 definitely confirm it also. So it looks like what we have here is galena, and definitely lead present here. I tested for copper. I added ammonia, and you should form some very brightly colored tetraamines like here. This is from a chalcopyrite sample that I've done before, and I got absolutely no color, so there's no copper there, so it's not chalcopyrite. And now I'll go ahead and do a spot test for iron with potassium ferrocyanide. This is a blank, and this is the sample. So if there was iron in there, this one would turn really blue. There might be maybe a little something in there, but not anything significant. So, no iron. Well, the spot tests were a perfect fit for this application. We got a very definitive result with a whitish beige precipitate on the first spot test, a black one in the second, and a bright yellow one in the third. And that's all very indicative of lead, and it didn't match the color or the iron. We actually went the extra mile and did the hydrogen sulfide test with the lead acetate paper, and found that it was a sulfide, and didn't see any blue copper amine color, and did a iron specific test that came up negative. So we definitely have a galena, which is lead sulfide. So anyways, I'll let my friend know. He'll be happy to know what that was. And thank you for watching the video, and happy rock and mineral identification to you.